In this video, we're going to do a quick review of whole number applications involving multiplication. For a longer video on this, you should look at the media lesson examples. So some common multiplication application forms are shown below. We have fair sharing or equal grouping. Number of groups times the size of the group in either order equals the total. The area of a rectangle, so we'll multiply the length times the width. Distance, rate, and time are related via multiplication, in that distance equals your rate or your speed times time, and a multiplicative comparison when one quantity is some multiplier, maybe 5 times as large as another. So let's just look at these applications so you can identify them, and you don't necessarily need to know the names, but you need to recognize their form. So John bought 6 comic books at a cost of $7 per comic book. How much did John spend? Okay, so this is an equal grouping problem, okay, and we can say that 6 books times $7, and I'm going to write this over books, okay, so it's $7 per comic book. So this is called unit analysis, and it can help you set up your problem correctly. So this would equal, the books will cancel, we'll have 6 times $7. So 6 copies of $7 gives us a cost of $42. Okay? You can think of this also as repeated addition, that you have 6 copies of $7, so you want to add $7 6 times. 5, 1, 2, 3, 4, 5, 6. Okay? And adding 7 6 times is the same as 6 times 7. Another example is the area of a rectangle. Tara bought a rectangular poster, so look for the word rectangular, or some things that you know would be rectangular. A poster board, a piece of paper, most of the time the room of a house, unless you have the Oval Office or a spherical house. It was 3 feet by 4 feet, and we want to find the poster board's area. Okay. And notice if we make a little sketch of this, if this is 3 feet and this is 4 feet, and we want to find the area, we want to find the number of square feet inside. So I'm going to cut this into 3 equal pieces for 1, so each one of these is 1 foot on the left. Then I'll cut this into 4 pieces. And now notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 square feet. So 3 feet times 4 feet equals 12 square feet, which is the area. Now we have distance, rate, and time. And remember, they're related by distance equals rate. Rate is like rate of speed, times time. Okay. So if we read through this problem, Sean biked at a rate of 12 miles per hour for 2 hours, and we want to know how far did he bike in total. Okay. So you should key in on the fact that we see the word rate, so that's a speed. This is giving us time. So if we multiply the rate times the time, we'll have the distance, which is how far did he bike in total. Okay. So let's multiply the rate. So I'm going to write 12 miles over hours times 2 hours equals, now notice I know I've set this up correctly because the hours on the bottom and the top cancel, and I'm left with miles, which is a measure of distance. So 12 times 2 is 24, and miles remain. And lastly, a multiplicative comparison. Jill spent $15 on a gift for her mom. Dan spent 3 times more than Jill, and we want to know how much did Dan spend. Okay, so we saw additive and subtracting comparisons, and it would say 3 more than Jill, but here we have 3 times more than Jill, so that's your likely your key indicator that you're finding a multiplicative comparison. So, Dan spent 3 times more than Jill. And I'm going to write what we know underneath here and what we're looking for. So we're given 3 times. We know that Jill spent $15. So the amount Dan spent is 3 times $15. Okay, so 3 times $15 is $45. And notice in multiplicative comparisons, there's only one unit, so they both spent dollars, and the 3 is just how many copies of 15. So another way to visualize this is 3 copies of 15. So Jill spent 15, Dan spent 3 copies of 15. Well, that's 3 times $15.